Determine the following limit. The limit, as the variable point xy heads towards the origin 0, 0, of the function x to the fourth times y divided by x to the fourth plus y to the fourth. Okay, so it turns out that this limit exists, and so different paths will all give the same result. So we're not going to check a whole bunch of different paths. Instead, we're going to give an argument that shows that this limit does exist using the Squeeze Theorem. So we're going to show that the function x to the fourth y over x to the fourth plus y to the fourth is between negative absolute value of y and absolute value of y. And this is because x to the fourth over x to the fourth plus y to the fourth is at least 0 and less than or equal to 1. X to the fourth and y to the fourth being positive, this denominator is at least as big as the numerator, and so the fraction is between 0 and 1. And if we know this, then the limit as xy goes to 0, 0 of absolute value of y plus or minus is going to be 0, because y is headed to 0, and therefore the absolute value of y is also headed to 0, and so is its negative. And if both of these limits are 0, then by the Squeeze theorem, the function in the middle must be headed to 0 as well. So this limit is 0 as soon as we can convince ourselves of this compound inequality. So we will use two facts. One is this one, which has already been explained, and the other one is that any number is less than or equal to its absolute value and greater than or equal to the negative of its absolute value. In fact, if the value of y is positive, then it's equal here, and it's bigger than this negative number. And if the value of y is negative, then it's equal to this one, and it's less than this positive number. And if y is 0, then these are all equal. So this is just a basic fact about absolute values that's true for any number. And then we notice that here we have a y, and then next to the y, we have this fraction, which we've said is between 0 and 1. So this is a positive fraction. So I can just take this positive number and I can multiply it by all three members of this compound inequality. When you multiply a compound inequality or any inequality by a positive number, you leave the sense, the direction of the inequality symbols the same. So this means that x to the fourth y divided by x to the fourth plus y to the fourth, that's multiplying the middle term by this fraction, will be less than or equal to x to the fourth over x to the fourth plus y to the fourth times the absolute value of y, and bigger than or equal to negative x to the fourth over x to the fourth plus y to the fourth times the absolute value of y. And now this fraction being less than 1 means that this number times this positive number is less than or equal to 1 times the positive number absolute value of y. So the original fraction is less than or equal to the absolute value of y. And now if we just look at this inequality here and we multiply both sides of it by negative 1, we get negative x to the fourth over x to the fourth plus y to the fourth. Absolute value of y is bigger than or equal to negative absolute value of y. And this quantity is exactly this quantity. So this quantity is bigger than or equal to negative absolute value of y. And so there you have it. Our function here, this is the f of xy that's in the limit, is between negative absolute value of y and absolute value of y. And then the limit as xy goes to 0, 0 of plus or minus absolute value of y is 0. And so that means that the limit as xy goes to 0, 0 of our original function, x to the fourth y over x to the fourth plus y to the fourth equals 0 as well, by the squeeze theorem.